Alright, this is our last video on 2.2 where we're talking about basic derivative rules and rates of change. So some other information relating derivatives and rates of change. We can say if a function, which we can say is represented by the letter S, represents the position of an object over time, represented by the letter T, it is called a position function. And it's quite interesting because the average velocity of the object can be found by taking the derivative of the position function. So we can say S of t that's the position function, and then if we find the derivative of it, so we find S prime of t, we can actually also write that as v of t because it's the velocity function. This actually leads us into our next example, example 9. So example 9, we have a billiard ball is dropped from a height of 100 feet. The ball's height S at time t is the position function. S of t is equal to negative 16 t squared plus 100, where S is measured in feet and t is measured in seconds. We want to find the average velocity over each time interval. Our first time interval we're going to look at is going to be from 1 to 2 seconds. So what we're actually going to do is we're going to find the slope of s between 1 and 2. So we're going to have to first find s of 1, and then we're going to have to find s of 2. We need those values. So if we put 1 into our position function, we're going to have negative 16 times 1 squared plus 100. Well, 1 squared is 1 times negative 16 is negative 16, and if we add 100 to negative 16, we're going to get 84. So we're going to hold on to that number. We need it in a little bit. We're now going to put 2 in for t. So we've got negative 16 times 2 squared plus 100. Well, 2 squared is 4. Negative 16 times 4 plus 100. Well, negative 16 times 4, that's negative 64. If we add 100 to that, we're going to get 36. And actually what we're going to do is we're just going to use the slope formula. We've got two x values. We've got 1 and 2 for our x values. S of 1 and S of 2 are our y values. And if you recall from algebra, finding the slope is just y2 minus y1 over x2 minus x1. It's just the change of y over change of x. So in this case, it's change of s over change of t, because we're dealing with s and t. So anyway, change of s. We've got 84 minus 36 over 1 minus 2. 84 minus 36, well, that is 48. 1 minus 2, that's negative 1, which means our average velocity is going to be negative 48 feet per second. Let's look at the time interval from 1 second to 1.5 seconds. So, again, we need S of 1, but we already found that in part A. S of 1 is 84. We do need to find S of 1.5. So we're going to go negative 16 times 1.5 squared plus 100. I would use a calculator when I'm doing this. If we square 1.5, multiply it by negative 16, and then add 100 to it, we're going to actually figure out that it's equal to 64. So use a calculator to figure out the 1.5 squared times negative 16. We're going to end up with 64. So now we're going to find the slope. We're going to go 84 minus 64 over 1 minus 1.5. So we're going to have 20 over negative 0.5, which comes out to be negative 40, which means the average velocity is negative 40 feet per second, which means this ball at or between 1 second and 1.5 seconds is falling negative 40 feet per second. So there is a way to figure out the position function when it's not given to you. We can write the position function s of t. It's going to be equal to negative 1/2. And I'm going to explain what these variables are in a second, but we're going to wait one moment as I write this. So negative 1/2 g times t squared plus v sub o t plus s sub o. This time t time g feet per second. G is that velocity under the influence of gravity. So on Earth, that velocity would be 32 feet per second. V sub 0, that is your initial velocity. And S sub 0 is your initial position. So let's actually use this idea and do an example. Our last example of lesson 2.2. So this is going to be example 10. We're going to say at time t equals 0 seconds, a diver jumps from a platform, diving board, that is 32 feet above the water. The initial velocity of the diver is 16 feet per second. We want to know, when does the diver hit the water, and what is the diver's velocity at impact, so when the diver hits the water. So we're going to do a few different things in here. The first one is we're going to write a position function. So we're going to use that format from the last slide. Remember, that format was S of t is equal to negative 1/2 gt squared plus VOT plus SO. Now, G, if we're talking about Earth, is always going to be 32. In this particular case, our initial velocity, 16 feet per second, and the diver's initial position, 32 feet above the water. So we're going to put these values into the formula. We're going to have negative 1/2 times 32 t squared plus 16t plus 32. And we're going to go negative 1/2 times 32 to simplify this, clean it up. So we're going to have negative 16 t squared plus 16 t plus 32. This is our position function. Once we've found the position function, the next thing we're going to do is we're going to find the time when the diver hits the water, and to do that we're going to set s of t equal to 0, and we're going to solve for t. And we can use any method we have in our arsenal. So I am going to do just that. I'm going to go 0 equals negative 16 t squared plus 16 t plus 32. And I'm actually going to use the factoring method because I do notice some things. I notice in those three terms they have a common factor. So we can start by factoring out a negative 16. So we're going to do that. We're going to factor negative 16 out. So we're going to rewrite this as t squared minus t minus 2. And then we can divide by negative 16. So 0 is going to be t squared minus t minus 2. And we can factor that some more. That's going to factor to t and another t. And we need numbers that are going to multiply to make negative 2 and add to make negative 1. The only numbers I know that can multiply to make negative 2 would be a negative 2 and a positive 1, or a positive 2 and a negative 1. So we're going to put a 2 and a 1 in here. And I do know in some way 2 and 1 can add to make negative 1. In fact, I need a negative 2 and a positive 1. And I'm almost done because now I want to figure out what values of t will make it 0. So I solve each factor. So one value of t is going to be 2, the other negative 1. But only one of these actually makes sense. We can't have negative time. So that means the time is going to be 2 seconds. Since we can't have negative time. There is one last thing we need to do. The absolute last thing we're going to do is we're going to find v of t by taking the derivative of s of t. And then finding v of 2. So let's start by finding v of t. That's just the derivative of s of t. So here is our s of t function. We have to break it up. So we're going to find the derivative of each term separately. Well, the derivative of that first term, we're going to bring the 2 down, so we're going to have negative 16 times 2t plus 16 plus 0. Well, this simplifies to just be negative 32t plus 16. So this is our velocity function. Now we also want to find v of 2, so we're just going to put 2 into there. So negative 32 times 2 plus 16. Negative 32 times 2, that's negative 64. And if we add 16 to that, we're going to get negative 48. So that means 2 seconds, the velocity when the diver hits the water is negative 48 feet per second. That actually wraps up our lesson 2.2.